So, Buntadura proposes a four-step model for the way we use technology as it becomes available within our teaching. The first stage is a substitute stage. We take something and just use the technology to do exactly what we were doing before. The augmentation stage, we've made a few changes, a few enhancements. But it's really only when we get to stages such as the modify stage that we've made wholesale changes to what it is we're trying to achieve from the learning opportunity. And then ultimately we have some kind of replacement stage where there's been a radical alteration to what it is that we've been trying to do that's been made possible by technology. Interesting thing is, in a computer lab, this is exactly what we can see happening with StatsEd. Substitute, we're just using the computer to pick and click, where before we would have plugged and chugged. We're just doing a few hand calculations within a computer. Then the augmentation would be, well, now we can do these on large data sets, why not do these kinds of calculations on real, meaningful data sets? But of course, the modify stage, we could start asking ourselves, what's this obsession with quadratic loss functions? Nice for plug and chug. Don't need to use that kind of thing anymore. But finally, for the R stage, of course, in StatsEd, we have things like randomization and resampling. So what we're trying to do is similar kind of inferential procedures, but by introducing these to the learning process, we're getting right at the very concepts that we're engaging underlying the principles of inference. My interests are more around feedback and assessment. So one of the difficulties with trying to model an authentic statistical discovery process is quite how we provide feedback. And of course, positive feedback is what reinforces the learning process. And of course, typically, at some stage we find ourselves in this scenario. There's a large group, maybe we're using something a little bit Socratic, calling questions out, looking for people to put their hands up. And of course, the obvious go-to technology to alter this situation a little bit would be some kind of clicker or zapper, where we're polling the students for some kind of feedback and we can respond accordingly. So the first thing we can do with that is a simple substitution process. What we're using the clickers for is to democratize that kind of setting. So instead of that one super quick student, super confident student who's quick to call out, the clicker zapper method, very widely available technology nowadays, lets us democratize the classroom. Everybody gets a chance to answer the questions. Augmentation would just be that it can change the flow of what it is we're trying to do in the classroom based on the feedback we're getting. But here's a kind of big change, modification kind of stage. This is the sort of peer learning that Mazur's doing. So now we get peers to justify their answers to each other. They've committed to an answer on the clicker, now they've got to justify it and explain it, and that gets you into some deeper learning. So the potential here, though, for really redefining or replacing what it is that we're trying to do is we can shift into much more conceptual territory now. And that's what I've attempted to show in that kind of sketch. Illustration of what I mean by that. A simple substitution kind of thing with some technology would be asking somebody to calculate a confidence interval by hand, pen and paper. Maybe they've got a calculator on their smartphone, lovely. Augmentation, we've maybe got a realistic scenario with some data that we've collected, and we're asking for some sensible inferential comments about what the confidence intervals tell us. With modifications, we're starting to get a little bit more conceptual. We might be asking about the widths of 95, 99% confidence intervals. Why would I use one or the other? But then the replace, we really do move into entirely conceptual territory. And here's a kind of model problem. So imagine we're going to an ice cream parlour. Very conveniently, it has a single queue, just so that we can model what we're interested in. How long do I have to wait to get served and given my ice cream? I'm going to model this by assuming waiting time is an exponential random variable. And the kind of question I might ask is, what is my waiting time given it's now 10 past 12 and the previous customer arrived at 12 o'clock? Would I expect that to be any different to a situation where the previous customer arrived at 10 minutes to midday?